You ready? Yeah, good boy. Welcome back, Motorized Bike enthusiasts. Grab your beverage of choice and enjoy the adventure. It has been raining a freakish amount of rain. It won't stop raining here where I live. But we finally got a break in the rain today, and it just so happened to be the first day where I finished all the electronic work on the Cranbrook. If you followed my community post, you know that we are attempting to build a street legal motorcycle. It might actually technically be classified as a scooter. I don't really know. I mean, I won't know unless I go through the process of getting all the things done. Let's see. I would have to get it inspected so that I can get a VIN number put on the bike and probably also the motor. And then I would have to get it titled, and then I'd have to get it insured, and then registered for plate and tag. But as far as components on the bike go, I believe I've got everything. Now, keep in mind, it's mostly just a fun project, but it might actually be a double-edged sword. I've never had any incidents with law enforcement riding in my town. The cops here are pretty cool. Most of them actually know me, and I just keep a low profile, and I ride as responsibly as I can. But adding all of these, I'm going to do air quotes here, adding all of these safety features to the bike might actually be shooting myself in the foot, because now the bike stands out quite a bit. There's nothing functionally different about the bike. It's actually technically safer now, but that might draw some attention. If I get pulled over and a cop asks me, hey, where's your license plate on this whatever this is, I swear I'm going to die inside a little bit. Anyways, let's have an overview of the bike. We added fenders, front and rear. Don't freak out about the fenders. I picked some that I'm confident are fine. We added a tail light, a functioning brake light with a brake light switch. We added a horn, rear view mirrors, turn signals, headlight, odometer, speedometer, and I think that's it. Yeah. Now, a few other things which weren't required in this actual process. I removed the coaster brake. That was an absolute nightmare. I'm never doing that again unless I have to. I have a question for you guys in the comment. If any of you have ever removed a coaster brake from the bike, what was your experience? Did it cause issues? Did you just remove the arm that mounts, the external arm that mounts to the frame, or did you remove the internal components, like the brake shoes? Let me know how that turned out. Mine's okay now, and it's mounted fine, and it runs true, but that was a nightmare. Oh, God, that sucked. Anyways, these are collapsible fenders. Hey, that's cool, because when you're not riding in the rain, you can telescope them in, and it puts less stress on the pivot and mounting points. The front fender is actually solid and mounts very securely. It's very simple, but it mounts nice, and I'm never going to have a problem with that. I can just tell by the way it mounts, and the materials that's used on these fenders is good. The rear one, I have a concern here at this pivot point where I think it might be a weak point. Now, I don't know if it's a weak point. The plastic is still pretty thick, but once I have determined the angle at which I have the rear fender is good, I'm going to go ahead and add epoxy into that gap at the pivot point to strengthen them even more. All right, for headlight and taillight. Now, we are running two taillights. One is included in the electronic systems I added to the bike. And the second one, which I'm messing with here in the video, is a redundancy one. It's just the one I was using for a while. It's bright, it looks nice, it lasts for a long time, it's convenient for charging, and it's redundant. Okay, so if the electronics on the bike fail, tail light, I'll still have a tail light. The headlight, I went ahead and just kept the one I already had on the bike. It's got a nice big battery. It's got a bright LED. It's not tied into the electronic system. And as far as I know, the component which draws the most power out of your electronic system is always going to be the headlight. It could be the CDI and spark plug. I don't know. I haven't measured amperage, but I know that these high-powered LED headlights can draw some watts. Everything else on the bike is pretty much minimalistic as far as power draw. So adding these components like the turn signal, tail light, brake light, horn, incorporating that into the charging system of the motor shouldn't be an issue. It's less than 3 amps. Even with, like, if you're holding the horn and the blinker and the brake lights all at the same time, it's less than 3 amps, so we're good. Now, these are cheap components. I didn't pick anything really expensive. Some of them are good, some of them are iffy, some of them just plain suck, and we'll get into that more as we go through the parts breakdown. But I didn't want to buy anything expensive on this bike because, well, this was a fun project, and I wasn't sure if I was going to be able to pull it off. By some miracle, I was able to hide most all of the wiring. When I was putting all this on the bike, this seems simple. It's not adding all that much to the bike. You got, turn signals, brake light, tail light, horn. And it's really it as far as electronics component go. But holy crap, do you have to add a ton of wires for that stuff. So the cranbrook's nice because of the way the frame has that kind of subframe in the middle. You're able to hide a lot of it. Using a lot of zip ties and Velcro straps, we're able to keep the spaghetti to a minimum. The turn signals, I chose these bar-in ones. Now, the LEDs that are included with them suck. They're not very bright during the day. They're fine. You can see them just fine at night. But in the daytime, they're pretty much useless. I'm going to be taking the actual included LEDs out and replacing them with some nice bright LEDs. But the assembly itself is really nice. It's all metal. It includes the mirrors, and they have thick metal mounting points with nice mirrors. And they're solid. They don't tend to move around with the vibration of the motor. So that's nice. The rear turn signals are mostly just auxiliary turn signals because I don't think they're actually spaced far enough apart to be legal. But since the bar-in mirrors can be seen from the front and the rear, and they're spaced very far apart, I think I've got that covered. That's a cool little reflection from my auxiliary tail light there on the fender. Now we have a speedometer and an odometer. And it's a proper odometer. The particular computer I chose, which once again will be in the breakdown of parts at the video, some probably towards the end, it's a true odometer. You can't actually go into the computer and reset it. There might be something funky you could do if you really tried, but there's no button you can push to reset the odometer. So it's a true odometer. Of course, it includes a trip meter and a thermometer. It also has a clock. It has a backlight so you can push it to see stuff at night, but it doesn't stay on. Has a solar panel, which claims to help take some stress off the battery in the daytime so that it'll save some battery power if you're riding around in the day. I don't actually know if that's a real solar panel, if it's even hooked up to anything. It's Chinese, so you know how they can be. But, hey, it's working. And the speedometer is actually accurate. Can you believe that? It has a setting in the computer where you can calibrate it to what size tire or rim you have on your bike. Since there's 26, there was a setting in the computer. I hit it's the 26 inch, and I tested it with my phone, and it's actually right. It's like within 1 or 2 miles per hour difference, but that's good enough for me. I also replaced the pedals on this bike. The ones that come with the cranbrook are just too small. There's no grip. So I put these metal Mongoose ones on it. They're really cheap, but they got some nice studs and a bigger footprint, so my feet shouldn't slip off as much. We added caliper brakes, which was part of the reason why I took the coaster brake out of the bike. Once again, I didn't take the coaster brake out because I had to. I just did it because I wanted to. And after I did it, now I don't want to do that again. But we have a double brake lever here, so one lever for both brakes, and that's an actual brake light switch mounted to the brake lever. So that when I pull the brakes, I got front and back with a brake light. That was fun. Trying to find a place to mount that was tricky until I realized I could just drill a small hole into the brake lever and mount it there. These stickers that say 49cc, some of you will get why that's on there. If you don't, then you should do some more research about legality of motorized bikes. But as far as everybody knows, this is a 49cc motor. So in case you were wondering, those stickers clarify that this is a 49cc motor. Now, with all these components on the bike, if I decide to register it as a motorcycle, that might not actually matter, and I could put whatever I wanted on there. But if we decide to register it as a scooter, we're good. We're good. And automatic transmission, which is a requirement in some states, yes, this has an automatic transmission. The the motor on this bike is automatically in one gear. It's automatically in first, no matter what I do. So there we go. That's my argument. Yeah, learn to love it. Now, this entire electronic system is not currently tied into the motor, because when I was ordering all the parts, I forgot one crucial component, which we will explain later in the video. But by this time next week, you guys should see this system working completely off the motor. I might keep the 12-volt battery on there for auxiliary purposes. I can't really think of why I would want to keep it on there. If the motor's not running, then I obviously don't need any of this stuff to work. And all these things combined, like I said, just like a 3 amp draw at max, maybe even less. And the motor should be able to handle that no problem. But the component I'm purchasing for this bike should take care of that. It's a voltage stabilizer and step down. See, I upgraded the magneto and the CDI. And the current magneto that I just put into this motor puts 12 volts out at idle and like 18 volts out at half throttle. So we can't try to charge our battery off of 18 volts, and I don't think we should try to run the components off of 18 volts, because the majority of my riding is going to be about half throttle, and the voltage would just be a little too much. So with the voltage stabilizer / voltage step down, that'll keep us at 12 volts, 3 amps, and we'll be good to go. It's essentially going to supply the same amount of electricity as the battery would. All right, let's go ahead and take it first. First test ride. Enjoy the video. Oh, that's awesome. Okay, now it's not the best equipment in the world. Most of it's all just cheap Chinese junk. But now that I know I can actually do it, I guess if it works out, then we will go ahead and upgrade some of the equipment as it breaks, which I almost guarantee it will. Yeah, that's pretty good. There. Alright, we are on a quest to go get something very important, but we're going to take a ride first. That horn ain't very loud. It says it only draws, I think 1.7 amps or something like that, which is well below our current draw, but still think it's supposed to be louder than that. At this point in the video, there are two types of people watching. One is just watching the video, and the other is currently typing on their keyboard about how I'm a terrible person for not coming to a full and complete stop at the stop sign. I'd like to take this opportunity to say that yes, you should come to a full and complete stop at a stop sign. And I'm also going to tell you that you're a hypocrite if you're currently typing in the comments about how I did not do that. Assuming that you have always come to a full and complete stop at the stop sign would make you a liar. Alright, let's enjoy the rest of the video, as I will not be coming to full and complete stops at every single stop sign when there is absolutely no traffic to be seen anywhere. Alright guys, so now we're going to go over the parts I used in this build, but please keep in mind this is a fresh build that was literally tested just once in the video you just watched. We do not know how long these parts are going to last. We'll find out in future videos what breaks and what doesn't. This is to give you ideas of what to expect if you're considering doing something like this to your bike, or at the very least, entertainment. Starting with the magneto, I decided to go ahead and upgrade the magneto on the bike since I want to try and run it as a charging system as well. I believe this magneto will do the trick, as when I tested it, it supplied more than 12 volts with a minimum of 12 volts at idle, and here's a quick clip of that. It came with a CDI and a spark plug. Didn't use a spark plug. It was too small. The threads looked correct, but everything else about it was too small. I did use the CDI. I did not feel a power gain. It might have been stronger. I really don't know, but it's working. So there's that. The bar and turn signals with mirror. This is an entire assembly here. And I like the fact that everything feels solid about it. The LEDs are crap. The wires included with the LEDs are super thin, but the important part is the hollow bolt that goes through the assembly is wide enough to accept nice thick wires should you choose to upgrade them, which I probably will. And the cavity for the turn signal LED is big enough to accept a bigger, more powerful LED, which we will be upgrading. The mirrors and the mirror mounting system is solid, and I don't see it being an issue in the future. I really like this assembly for its price. The computer I'm using for the odometer, speedometer, timer, clock, thermometer, all that good stuff. Here it is. And that's it. As mentioned, you already know why I chose to use it on the bike. Proper odometer and an accurate speedometer. Upgraded the pedals. These are some just basic Mongoose pedals with good reviews. They have a wide footprint, nice studs to help keep grip, and they'll work on pretty much any bike that I could think of. They have adapters in case you have a crank that accepts these particular threads. So, yeah. For the Cranbrook, I did not need to use the adapters. The stock threads were the right size. Stop light switch, brake light switch, whatever you want to call it. Here they are. I got the 2-pack because I wasn't sure if I was going to use one on each brake caliper or how I was going to mount it to the bike at all. I got lucky when I figured out how to mount it to the brake lever by drilling a small hole and soldering the actual wire to the brake lever. I basically took the wire, bent it at a 90-degree angle, put it through the hole, and then added a bead of solder to the top and the bottom, and it looks like it's going to work for a long time. The quality might not be great. It's all plastic, but they're working right now. The controls I used, here it is. This is the control I used for the running lights, the turn signals, and the horn. Keep in mind, this does not have an off position for the running lights. It has a low and a high position. For me, that's not an issue because I'm not using a headlight in the circuit. That might be an issue for you, but I'm using the low beams or close beams as off, and I'm using the high beams as on for my tail light. The only thing that switch is running is my actual tail light. But keep in mind, if you do decide to use this particular one, then once you turn on your battery or turn on your motor, depending on how you're powering your system, you will have a running light if you're using a low and a high beam. All right. Oh, and this wiring diagram is inaccurate, so you will need to have a multimeter to check what each one of these does. That's really not a problem. It just adds a little bit more time to your build, whereas you need to check individual wires with the multimeter to find out which one the horn is and which one the turn signal is and all that good stuff. But it's cheap and the reviews are good. This thing had hit and miss reviews. I don't think it's going to last very long, but this is what I'm using for the taillight assembly. It's got turn signals, it's got a running light, a brake light, and an illumination for a license plate. The assembly itself does not appear to be waterproof at all, so I sealed right here around the edge with Gorilla Tape to help keep rain out of it. And I also sealed the wire grommet with silicone. I sealed this with silicone to help keep water from getting up in there. So as far as I know, mine is now waterproof, but I don't know if it's going to withstand the vibrations of the engine. We'll find out in the future. I'm pretty sure I'm going to have to upgrade that, but for now it's working all right. The flasher relay I'm using, this particular one here, adjustable. It works with LEDs. That's the important part. You can't use a regular flasher for incandescent bulbs on LEDs. It just won't work. This one's adjustable, and you're more than likely going to have to turn this little dial to get your flashers to start working. Once you do that, after you get your flashers working, everything's adjusted, you're going to want to go ahead and seal the entire bottom of this with something to keep water out of it, because this is not waterproof. Or at the very least, make sure it's not turned upside down so it doesn't fill up with rainwater. The battery pack I'm using is here. It's a basic battery pack, 12 volt output, also has a 5 volt if you want to use the USB port for charging like a phone or something. It's fine. It's 12 volts, 3 amp maximum output and charging. So that's 36 watts. It's actually the exact same as the charging system component, which I'm going to show you in a few moments. It's not waterproof, so keep that in mind. If you do decide to use a battery pack on your build, you're going to need to keep this one inside of a water-resistant pouch at the very least, which is what I'm doing. Also, I do not recommend hard mounting this to the frame of the bike, where the vibrations will more than likely destroy the circuitry inside of this battery pack. I'm almost certain of it. So mine's mounted inside of the water-resistant pouch, which acts as a buffer to keep vibrations away from it. So the battery pack itself is pretty loosely mounted to the bike, but it's still secure, so I think we'll be alright. The fenders I chose, multiple different colors. They're cheap. They've got hit and miss reviews, but as far as I can tell, if mounted properly and secured and reinforced, these shouldn't be an issue. The big deal for me is that they're telescoping, which removes a lot of stress from the mounting points when you're not using them. They have multiple ways of mounting to the bike, both by mounting to the caliper bolt if you have caliper brakes, or clamping onto various different posts of the bike. Like my rear one is clamped onto the seat post here, and my front one is mounted to the caliper style brake where the bolt goes through right here. And there's that. So we'll find out how they last. The horn I'm using, this one right here, it's super basic, 12 volts, 1.5 amps. At 1.5 amps, I assume I do not need a relay for this horn. However, when I tested it, I noticed it's not very loud. It's loud enough to catch the attention of people walking and next to you, but not loud enough to catch the attention of a motorist. They're just not going to hear this through their car door. So keep that in mind. This could simply because I'm not using a relay. Maybe I need to boost the amperage, but I just assumed I wouldn't need to at 1.5 amps. We'll find out as I try and boost its power output in the future. The identification stickers I'm using for the bike, I chose to go with these ones. They're just basic stickers. I don't know if they're going to withstand the heat of the motor. The cover over the magneto doesn't tend to get very hot from what I've seen, so I think these stickers will be okay. It gets pretty warm, but not really hot. At the very least, I can put them on that cover, paint the cover, then take them off, and they'll be good as stencils, but whatever. I cleaned the area with rubbing alcohol before I put these on to make sure they had a nice surface to adhere to. And the only component which I don't currently have on the bike, which we should have by this time next week, is this voltage stabilizer, converter, step down, whatever you want to call this thing. It takes input voltage from 8 to 40 volts, which is well within the margin for our motor, our magneto, and outputs a relatively stable 12 volts with a maximum output of 3 amps. 3 times 12 equals 36 watts, which is identical to the battery pack we're using on the bike. Since the battery pack doesn't appear to have any trouble powering all of our components, this should work just fine, assuming that our motor's charging system, which is what I'm going to call it from now on, can supply at least 3 additional amps after supplying power to the CDI. 3 amps, I think it'll be able to do that, but we won't know until we test it. And also keep in mind, that's not necessarily what the electronics on my bike are running. 3 amps is the maximum output on the battery, but I know I'm not actually pulling 3 amps out of it all the time. You know, the LED turn signals and lights take considerably less power than an incandescent bulb, and from what I understand, the stock low-powered CDIs or magnetos can power a 6-volt incandescent bulb, which is probably more than 3 amps. I don't know. We're going to find out, guys. Stay tuned, anyways, that's going to do it for this video. I'm not going to have time for answering or replying to viewer comments in this particular episode. We're going to go ahead and do another video sometime during the week, replying to some viewer comments with probably some additional information about the bike as we ride it. So look for a bonus video before Friday. I can't guarantee it. I think we'll have another video soon. All right, guys, thanks for watching. Ride safe.